Okay, we are on 2-6, which we are doing, solving linear inequalities with it this time. The big thing to remember on inequalities, working exactly the way you do equalities, the biggest difference is if you multiply or divide by a negative number, you gotta flop that symbol over. So if I'm working this problem here, it works out better. Now you can take the variables to either side, but it works out better if you get the variables on the left. So what I'm gonna do first is move the 2x over. Remember, you do that by adding the opposite. Now what are we going to do?
Take 5 to the other side.
Take 5 to the other side, so if it's -5 there, it'd be a +5. I get 5x is less than 11. Divide both sides by 5. X is less than 11/5. If he says graph them, all I really need to see on your graph is just put 0. Now since this is a fraction, it's going to be somewhere between 2 and 3. And put a dot there and you write 11/5 there. Less than, so it's a circle because it's not equal to, and it's going that way. So the big thing is just get the number between the two whole numbers.
That'd be 2.2.
I'm going to leave it as fractions. The only time you get to go to a decimal is if he starts off as a decimal. Other than that, leave it. Any questions on that? Okay. Let's look at a different one. So on this one, I have got 13 minus 7x is greater than or equal to 10x minus 4. So what are we going to do first?
Get the variable to the left side.
Okay, so I'm going to take it to the left, so I'm going to add a -10x to both sides. So I got 13 minus 17x is greater than or equal to -4. Subtract 13, take your numbers to the other side of the equation. You multiply by -17, you divide by -17. Now since I divided by a negative number, flop the symbol over. One of the most common mistakes on that is people think it's the answer. I don't care about the answer, I care what I divided by. Since I divided by -17, you gotta flop the symbol. So be sure to flop that over. Everybody all right? Okay. Next thing we got is called compound inequalities. I got -3 is less than 2x plus 5 is less than or equal to 7. This is called an and statement. Okay, it's because both things have to be true. And statements are the intersection of the two answers. I used to always teach this by working two problems. Now don't copy this down, but we would work it like this: 2x plus 5 and then you do the 2x plus 5 again. Some students sometimes say, well, can't we just do this the way I'm getting ready to show you? And I'd say, no, you can't do it. And it may have actually been in the college algebra book, which I believe it is, that they actually showed it the way that whoever this was. So I think this works a lot easier. I'm just going to work it like this. And what I'm going to do is here's the middle, and I'm going to work two problems at one time. So I got to get the 2x by itself, so I would subtract 5, right? But to do that, I've got to subtract 5 3 different times. Now that would give me a -8 is less than 2x is less than or equal to 2. If you multiply by 2, so what are you going to do?
Divide by 2.
Divide by 2. So I divide both sides by 2. -4 is less than x is less than or equal to 1. And that's my answer. If he says graph, then all I need to do is just put these numbers down. Oh, I messed up right here. So let's try it again. This is not equal to, so it's a circle. This one is equal to, so it's a solid dot. And it's just a line joining.
So when it's and, you only go to the next or corresponding spots.
Every and statement should look like this. Now, let me rephrase this. 90% of the and statements look like this. It is possible to get and statements that do this when you graph them. You know, you got your two numbers down here, and I'm just making up these numbers. That they go opposite directions. Now, if my answer is the intersection, where do they intersect?
No.
They don't. So your answer on that would be the empty set.
And what if it's like 7 and then the arrow goes to the right, 12?
So what would happen, let's just call that A and B, and let's say they go this way.
All real numbers,
No.
or all,
See, right there's where the intersection is, isn't it? So it'd just be greater than that number.
Yeah.
Or if it went the other way, it'd be less than that number. So there's three possibles that you can get. Okay, now I'll be honest with you, I don't know what this is gonna look like, or that's gonna look like working it out this way. It is possible to have an and statement that has the word and in between it. Okay, so you need to graph it just to make sure. One thing that you can do, when you get down here, these symbols both better be pointing in the same direction. If they're not, either you made a mistake or it's gonna be one of these special cases. So just kind of look at it and see. The other compound inequality you can have is what we call an or statement. Or statements are really hard to tell that they're an or statement. They have the word or in them, so it's really not that hard. You got two problems, so we're going to work it. This is a -7 here. Add 5 to both sides. You got 2x is less than or equal to -2.
Oh.
Okay. He multiplied by 2, so what are you going to do?
Divided by
Divide
2.
by 2. I get x is less than or equal to -1. I'll hold on. So that's the first answer. Now let's go do the next answer. Work the problem the second time, add 5 to both sides. 2x is greater than 6. Divide by 2, x is greater than 3. Graph it to make sure it's not a special case. So I'm going to come down just, again, I just put those two numbers down. If the variable's on the left, the inequality will point the direction the line's going to. Solid dot because it's equal to, it goes this way. Circle 3, it'll go that way. 90% of the or statements ought to look like that. So if it does, it's just, your answer will just come back up here and write the or in between it and circle it, and there it is. What would happen if we have an or statement and it does this? Now, I forgot to tell you this. Okay, this is an or statement, and it is the union of everything. Okay, so if the answer looks like this, B would say every number to the left. A would say every number to the right. So that would just be all numbers. Everybody all right on that? Because this gets every number less, and I got every number greater. So
Oh, I'm still thinking about the intersection.
yeah, it's not the intersection, it's a union, so it means everything. Okay. So what would happen if it does this?
All integers?
No,
Or whole
Everything above
numbers?
A.
everything above A. See, that would get everything, wouldn't it? Okay. So again, 3 different cases. Normally they look like this. This is your special case, and that's another special case. But this will give you all numbers, where the and statement gave me the empty set. With it. Then we get into absolute values. So I've got the absolute value of 3x plus 2 is less than 5. You need to make a note somewhere that if I have an and statement, which is less than will be an and statement, and greater than is an or statement, and if you have an equal to, it is an or statement.
For absolute value only.
Absolute values, these are for absolute values. Dalton, you with me?
Yes.
I can't tell if you're zoned out and just talking to me, or if you're just concentrating so much.
More zoned in than anything.
Okay. To do the absolute values, I gotta work it twice. Because the truth is, if I work this inside and it comes up to be a -5, then the absolute value of a -5, well, let's say -4, then it's still gonna be less than that, isn't it? But if I got a +4, it'd be less. So you gotta take into consideration that. This is a little trick with the and statements that will work. Remember how we worked that before? If you just come down here and put another less than symbol and change the sign. So what I do, we brought this over here and I changed the sign.
Do you have to flip the?
Now it's still less than. Both of these signs should be pointing the same direction. You literally did flip it, because look, that would say that was greater than, where there it says it's less than. But if you just put
Okay.
inequality in front, it'll work.
But writing it down, they're going the same way.
Yeah. Subtract -2 from both sides. I get -7 is less than 3x is less than 3. Divide both sides by 3. So I got -7/3 is less than x is less than 1. Now how would you graph that? It's between 2 and 3, isn't it?
Yes.
Put a dot there. Actually, it'd be
No, it's between 3 and 2, yeah.
3 goes in there 2 times. Okay. Put a circle there, my bad. You come over here to 1, put a circle, line join it. Again, if you come down here and these symbols are pointing in a different direction, then you really need to graph it, each one of them separately, to see what happens to your answer, because it's probably a special case. Any questions on that? It adds one step to us, doesn't it? If you can go from here to write it, then it's just like the problems we've just been working.
Well, yeah, that's negative 2, isn't it?
Okay, here we go. This time I got the absolute value 5 minus 2x is greater than or equal to 1. So is this going to be an and statement or an or statement?
Greater than is or.
Or statement, okay? So I'm going to work it one time the way it's written. And Bailey kind of touched on it. Work the exact same thing, flop the symbol, which means you actually change it. Flop the symbol, change the sign. So it's less than or equal to -1. We actually were doing this in my Algebra 1 class today, this same stuff. Subtract 5. -2x is less than or equal to -4. Divide both sides by -2. Flop the symbol because you divided by -2. You get x is less than 2. Go ahead. Okay, work a second problem. I'm gonna wait till you start back to your desk before I start talking. I'll let you get caught up. Everybody got it?
Yeah. X is greater than -2.
I'd actually like to see it on your paper, and you're wrong.
Didn't I?
Yeah,
Should be 3.
No, I added the 5 instead of subtracted it.
and it's greater than,
That's what happens when you do stuff in your head.
and it's greater than, not less than.
I said greater than,
Oh,
X
did
is
you?
greater than -2.
Now, graph it just to make sure that you don't have a special case. Less than or equal to 2 goes this way, greater than or equal to 3 goes that way. That's what it ought to be. And we're right there. You are going to have some application problems, which is a nice way of saying that you are going to have some graphing problems, okay? What you need to keep in mind is that if it says is at least, that means greater than or equal to. If it says is at most, then that's less than or equal to. Okay? Looking at the homework on page 248. Okay, let's see what the assignment says on a nice little paper here. I have got on this that we are doing multiples of 4 through 64 multiples of 4, which would be about 16 problems, right? So I think you can handle that. So we are on page 240, we'll call it page 248. You're going to go 4 through 64 multiples of 4.